We already know that variance, again, of the discrete random variable x is ex squared minus e of x, and this is all squared. And again, that's the capital and that's the capital. Those are both the discrete random variable. I wish it was that easy, but we also have properties of the variance. For example, if a is a constant, the variance of a is 0. Well, we're talking about spread about data. If we just have a constant, there is no spread, so it makes sense to me anyways that the variance is 0 if we're talking about a constant. The variance of a times our discrete random variable means we're going to have to move this a out in front and make that, well, variance is all about squaring. Look, here's our formula, we're squaring. So it makes sense to me that we're going to, if you buy into the fact that we can move this a out in front, that it's going to be squared. So it would be a squared times the variance of x. And finally, if I have ax plus b, well, again, variance measures spread. So if we're spread around 0 or we're spread moved over to be around some number b, that doesn't affect variance. We can move variance this way or that way according to b, and our variance will stay the same. So again, you could almost treat variance ax plus b as if it's variance ax. It's almost as if the b doesn't matter. We're still just moving the a out in front and squaring it and finding the variance of x. It doesn't matter where our data is. We're just worried about the spread of data when we're talking about variance. So you need to know these. You need to commit these to memories. If a is a constant, the variance of a is 0. If we're talking about variance of ax, bring the a out front, square it, so it's a squared variance x. If we're variance ax plus b, it's as if the b doesn't matter, bring the a out in front, it's a squared variance x. Let's do some examples so this becomes more concrete in your mind. Here is a typical problem we may face when dealing with expected value or the expectation, variance, and standard deviation. A discrete random variable, capital X, has this probability distribution. Our capital value x, right here, can take on the value of small x. Our discrete random variable can be 0, 1, 2, 3, or 4. What are the probabilities associated with each of these? Well, here they are. 1 over 16, 3 over 16, 7 over 16, 3 over 16, 2 over 16. To do an expected value problem, or to find the variance, or to find the standard deviation here, this is our starting spot. If you don't have this, you don't know what to do. So anytime you're talking about expected value, you need to know what are my x's being and what could the probabilities be. Once you have that, the expected value is quite easy. It says this times this, plus this times this, plus this times this, plus this times this, plus this times this, which I've laid out here. 0 times 1 over 16, plus, etc., all the way down. When you add those up, you get 34 over 16, which simplifies divide by 2 to 7 over 8, which you can write as 2 and 1/8, or I put 4 sig figs here, you should be using 3 sig figs, 2.125. We found our expected value, our long run expected mean value. Let's now find variance and standard deviation. So here is my probability distribution. I just found the expected value was 2 and 1/8, which I'm going to keep as 17 over 8. Now I'm asked to find the variance of 4x plus 2. What do I do? Well, I know from my properties of variance that the variance of ax plus b is, bring this a out and square it, a squared variance x. Well, I know how to find variance x. How do I find variance x? Variance x is equal to the expected value of x squared minus the expected value, the whole thing, squared. Okay, do you see how important it is to know this stuff cold so you can apply it? Well, if we're going to find the variance of ax plus b, then this here is my a, which I'll have to bring outside. 4 outside squared is going to be 16. Alright, I know I'm going to have 16 out in front. I need to find variance x. I need to follow this formula, which requires me first to know the expected value of x squared. Well, that means I'm going to take 0 and square it and multiply by 1/16. It's associated probability. 0 squared times 1/16. We're taking the sum, so add that to 1, because I'm finding x squared, 1 squared times its probability. Add it to 2 squared times its probability, right there. Add it to, we plus 3 squared times its probability. Add it to 4 squared times its probability. Why are we squaring it? Because we're not finding the expected value, we're finding the expected value of x squared. Well, when I go through all the machinations of the math, it turns out this is 90 over 16, which simplifies to divide by 2, 45 over 8. So I'm going to write here e of x squared is 45 over 8. I know that I have to use this formula, and I've got this now, and I can take this and square it and get the second part. Let's see how that works out. Now we're in the position to finish this problem. I know that variance of ax plus b, where a is 4, is going to be a squared variance x. What's my a? It's 4, so it's going to be 4, I took the 4 as a, squared variance x. Well, variance x says e x squared, which we found as 45 over 8 minus ex. Well, what is ex? It's 17 over 8, and we have to square that. Well, we're going to square that in there. So this is taking care of small details with math. Bring whatever your a term is out, square it. Our a term was 4, we bring it outside and square it. Times the quantity, what? It's going to be variance x. Well, what is variance x? So we're going to really be multiplying by this whole thing. Ex squared, we found is 45 over 8, minus our expected value, which was 17 over 8 we found originally, squared. When I do all the math, and you certainly can do the math, you get 71 over 4. I don't need to go over how you find this as 16, find common denominators, etc. Let me just go back to this problem for a moment, if I may. We did this correctly, and we found out because our a squared was 4 squared, it turned out that if we're doing this as fractions, this became 16, which is 4 squared, times, in here, this simplified to 71 over 64. Well, then I canceled 16 and 64, and I got 71 over 4, which is the answer to this problem. What is the variance of 4x plus 2? But if I'm just looking at the variance of x, this is variance of x, which is 71 over 64. We just found out our variance was 71 over 64. Let's tuck that away in our brains and remember that. We found that in our last problem. Well, we also are using this principle. Variance of ax plus b equals, bring this a out in front. Remember, that's the coefficient of your discrete random variable. You're going to bring it up front and square it and multiply by the variance of x. Here's our new problem. Find the standard deviation of 3 minus x. Well, first, if we know that sigma squared is variance and sigma is standard deviation, we have to remember that to go from sigma squared to sigma, we simply are going to be taking the square root. Find the standard deviation of 3 minus x. Well, I want it in the form of ax plus b. So I'm going to call this, let's find the square root of the variance of, instead of 3 minus x, I'm going to say negative 1x plus 3. Now, why did I write the square root of variance? Well, because that's what the definition of standard deviation is. I want to take the square root of the variance. Well, what is the variance of negative 1x plus 3? Remember, we don't have to consider that b term. We're just concerned with moving that negative 1 out in front and squaring it and taking the variance of x. And then we're going to take the square root of the whole thing because we don't want the variance, we want the standard deviation. Well, this is easy because negative 1 squared is 1. So really what we're going to find is the square root of variance of x. Well, what did we find in our last problem, what the variance of x was? For this set of data, we want the square root of the variance of x, which is, we found out before that the variance of x is 71 over 64, so it will be 71 over 64, and we will take the square root of that, and that will give us our standard deviation. Notice this problem is a little tricky. I had to switch this using the commutative property of addition, and recognize that standard deviation was just the square root of variance, and then I had to use this rule. Not a hard problem, not a whole lot of math here, but you did have to know some things.